Hello, and welcome to some more chemistry. I'm your host, Mr. Hicks, and today we're going to talk about writing formulas for ionic compounds. They call this nomenclature. Nomenclature is a system or a set of rules for writing the names and naming things and to write symbols. And so that's what we're going to take a look at today, this system of rules for writing the names and formulas of ionic compounds. Now here's what we're going to be able to do. We're going to take the name of an ionic compound, like sodium chloride, and we're going to be able to turn it into its symbol form, the chemical formula here. There are some variations to this, 3 of them. One of them is a binary compound. This means 2 elements that's a part of it. Sodium chloride is a binary compound. It has just sodium and chlorine. Then we have tertiary compounds. These are ones that contain what we call polyatomic ions. A polyatomic ion is an ion that's made of many atoms. It's a group that stays together. And finally, some of the cations that we encounter will have more than one charge. And so we have to be able to account for that to make sure we're speaking of the correct cation. So here's my process that I suggest doing. We need to first know what the name has for us, and we have a convention with these where we always list the cation as the first name and the anion as the second name. So for instance, like sodium chloride, the sodium is the cation and the chloride is the anion. So it's best if you have some type of a chart that has the ions there for you, that you can take a look at those ions and know what their formulas are and see what their names are, get all of the charges straight. If you don't have one, there's several of them on the internet that has all of them, or maybe in a textbook. You might even employ some of your smart devices and be able to find things on the internet as well. So I have my little charts over here, cations and anions, and I'll pull those out for a couple of them so we can look at them. Let's start with the easiest one down here. So I say that the first step is to write down the symbol and the charge. So it's important that you go into your list, whichever one you're going to use, and you take a look around and you try to find exactly what it is. So the name here is sodium. So you need to make sure you go into your list, find sodium, and see what ion it is. Here we can see that it's Na with a little plus up there. If you don't understand why that plus is there, there are videos that I have that talks about where that plus comes from, what does it mean, what's a cation. You may want to jump back in the series and pick up a couple of those. So for sodium, I'm going to write down its symbol and its charge, be Na with a plus. And I'm going to do the same thing for the anion. I'm going to look in here and find chloride. Now you have to be careful because a lot of things have very similar names. And so down here you can see here's chloride, chlorite, chlorate. Got to make sure that you're getting the right one. The ending changes depending on the different ions. So in this case, this is what we call a monoatomic anion, or made of just one atom. And so the name and the end we choose to be IDE, chloride. So the symbol we want here is just Cl with a negative. I'll write that down. And the last thing we have to do is crisscross our charges to balance everything out. And in this case, we got +1 and -1, so they already cancel out. And so I can just clean everything up. Notice when I have my final compound here, the formula, that I don't have any charges in it. Charges have been canceled out, so we don't write them in there. Let me try one more. and I'll give you a shot. Magnesium bromide. Again, go into your lists, look for magnesium, and when I look on my list, I see that it is Mg with a 2 plus. And then for bromide, search around in the anions list for that. And I'm going to find it. It's in the same family as chlorine over here. So it's also going to take on that -1 charge. Crisscross. I call it crisscrossing, but it's really just a way of canceling out the charges. If you aren't familiar with that, or you don't know how to go about canceling out the charges of ionic compounds and go from their symbols to their formulas, then you might want to jump back a video or two and check that out, or check it out in a textbook or something like that. So for this one, the 2 is going to go over here with the bromine. Nothing's going to come down here for the magnesium, and my formula ends up being MgBr2. I need 2 of these -1 bromines to cancel out the +2 of the magnesium. All right, I'm going to give you a little time to work out aluminum sulfide. Okay, how'd you do? So aluminum, that has a +3 charge. And sulfide, of course, you double-checked everything to make sure you got sulfide instead of sulfates or sulfites. It has a -2 charge. Crisscross those charges, and you end up with Al2S3. Let's take a look at some of the variations that we have. We said that one variation on this is one that's typically seen as a cation. And some metals can have more than one charge. These are usually transition metals, and their d electrons make it so that sometimes it loses d electrons to become more stable. And so the atom has a choice to lose just the s electrons from the highest energy level, or losing some of the d electrons from an energy level below that. So for our purposes right here, we need to know, how can you tell what charge this particular ion is for this transition metal? So the way to know is with these Roman numerals right here. The Roman numeral is telling us what the charge is. This Roman numeral goes with the cation. So it doesn't go with the chloride, it goes with the iron over here. So this tells me that this iron has a +3 charge. And you can see you have to be careful, and we have to point this out, because if we take a look at our list over here, here is iron with its +3 charge, and over here is iron with its +2 charge. So there are 2 variations on that, and that's why we use the Roman numeral to point out whether it's +2 or +3. So now that I know it's iron with the +3 charge, I can write that down. I can do my chloride. I've seen that before. That's a -1 charge. Crisscross. And I get iron chloride. Iron 3 chloride, we say. Why don't you try the copper 1 oxide and see how you do with that? All right. Find everything. Copper 1, I know we have this Roman numeral 1 here to show that copper has a +1 charge. So we write down copper, +1, And oxide over here. Making sure you get the right one. And crisscross. Okay, the last variation is what we call polyatomic ions. Polyatomic ions are a group of atoms that are combined together that stay together, but yet they have a charge overall. There are a few polyatomic ions that are positively charged, but most of these are going to be negatively charged. Now for the anions, we are going to change their names when it's a group. Kind of like Spanish class, right? You conjugate the verb depending on whether it is a singular thing or whether it's multiple people involved, like a me or a we. We change the name, we change the ending of the name to designate that. So far we've been looking at what we call monoatomic ions, one singular element that's a part of it. And so we've been seeing that their names end in ide, IDE, chloride. With these groups, however, it's going to be made up of more than one element, and their names are going to end in different ways. So you're going to have eights or you'll have ites. Now down here I can see potassium carbonate. Okay, so I know that this is going to end with, it's going to be a group of elements that are together. So I go to my chart, and let's take a peek at mine here for a second. And on my chart, I'm going to look around for carbonate, and I think it's in the -2s over here. There it is, right on the top, carbonate. Okay, and you can see there's lots of them here that have more than one. Here's carbon and oxygen. This one's chromium and oxygen. This one's silicon and oxygen. Here's sulfur and oxygen. Boron and oxygen, phosphorus and oxygen. So there are many different polyatomic ions that contain oxygen and maybe other things. And when they do contain these other elements, and it is a group, we tend to change its name to eights and ites. So that's how you'll be able to tell what you're looking for, maybe. Give you a hint at least. So carbonate, taking a look at that symbol here, our symbol was CO3 with a -2. I'd like to point out a couple of things here. First of all, the 3 down here, this 3 belongs to that oxygen right there, and it's going to stay with it. That tells me the number of oxygens in this group, and it stays with it. As long as it's a group and doesn't chemically decompose, that 3 is going to be sitting right next to that oxygen, because it tells me I have 1 carbon and 3 oxygens in this group. And then the number that's superscripted up here, this number here, is the charge. And the charge is what we need to balance out. We need to do our crisscross with, right? And in the end, it'll go away because we're going to balance it out. So, let's see how we put this together with the potassium. I look up my potassium. It's a +1 charge. And I look up my carbonate, and I write everything down about it. -2 charge. And now the 2, I need 2 of these positive 1s over here to cancel out the -2. And so my formula is going to look like K2, because I need 2 of them, CO3. See how that 3 is still right next to the oxygen, because it's telling me I have 3 oxygens in this group. That's all one group that's attached to these potassium ions. Let's try another one, chromium nitrate. This has a surprise for us. Chromium nitrate, I'd have a chromium 3, and I have nitrate. And I'm going to look that up. That's a NO3 with a -1 charge. So again, numbers down says 3 oxygens. That's going to stay right next to that oxygen. And numbers up, the charge. That's what we're going to use to balance out the charges with. So I only need 1 of these chromiums, but I need 3 of these nitrates. I need 3 of the whole group, the entire nitrate group. So the way that we show that we have 3 of those nitrate groups is we put them in parentheses. So I'm going to take my 3 and move it down here. Nothing's going to move over there. And my formula is going to be chromium, just 1, Cr. And then inside parentheses, I'm going to put the NO3. See how that 3 is still with the oxygen? And then outside of that, I'll put a 3. And this says that I have 3 of everything that's inside of that parentheses. 3 of those nitrate groups to cancel out the +3 charge of the chromium. Well, it's time for you to have some practice here. So I got some up here that you can work on. In fact, I'm just going to go ahead and pull out both sets for you to work with. And you go ahead and press pause. And then when you're ready, you come back and I'll throw the answers up. And you can see how you're doing. Okay, time for some answers. Are you ready? The copper hydroxide many times is a tricky one because we need 2 of those hydroxide groups with their -1s to cancel out the +2 of the copper. So since we need 2 of the hydroxide, we need to put parentheses around the O and the H. This one's tricky because it doesn't have another number on the outside of the H, and so people forget to put that in there sometimes. Did you get all the numbers to stay in their right places? And there you go. Well, we've learned how to take the name of an ionic compound and change it into a formula. And we've seen 3 variations of this. So hopefully you're feeling more confident with that. And good luck with chemistry.